In this video we learn how to program an Arduino Uno for the very first time. The Arduino is very good at doing the job it was designed for, which is basically turning electronic inputs into outputs. It does this rapidly and cheaply, but writing programs, or sketches as they're known, are performed on a separate machine and then uploaded onto the Uno for execution. The world is a beautiful place, full of very talented people who combine to produce free, open source software for us to use. One group can be found at www.arduino.cc. They've produced what is known as an IDE, an Integrated Development Environment. Don't worry about the words for the moment, just be aware that once we've downloaded their software, we have the ability to program Arduinos for ourselves. The software created by the Arduino group is magnificent. They produce software that is platform and operating system agnostic. Another way of saying this is that they have ported their software to run on desktops or laptops, tablets or mobile phones. They don't care what device you use. It works with most popular devices or platforms as they are known. Operating system agnostic also means that it does not matter what operating system you are running, whether it is any form of Windows 7 or 8, Linux, Ubuntu and Mint are popular distributions, Raspbian on the Raspberry Pi, Android, or even Macs running their software. It's platform and operating system agnostic. Most operating systems now make software installation a breeze. On an Android device, you can just search Google Play for Android Drone and then press the install button. In Ubuntu, just search for Android and the installer should take care of the rest. In Windows, just go to the website, click on the Windows installer link and follow the instructions. If you have an Apple device, then you obviously have too much money to waste on devices. Ask your butler to do it for you. Here we will demonstrate how to install it on the Raspberry Pi. Start a graphical session and move through to the terminal setting. Enter apt-get install Arduino. If the Pi is connected to the internet, it should fetch and install the software. The time taken will depend on your internet access and your Pi settings. Once completed, return to the Start button to reveal the new Electronics section leading to an Arduino IDE section. Click on this to begin a session. There are two settings that have to be configured whatever system you are using. The first is to ensure that the Uno is selected from all the different types of Arduino that exist and are shown on the list. Go to Tools, Board and select Uno if it's not already selected. Now connect the Uno to any convenient USB port on your machine. The second setting tells the IDE what USB port you've just connected. Again, click on Tools and Serial Port. The Pi has installed Uno on /dev/tty/acm0. Your selection may vary. With the hardware connections established, you can concentrate on software. Rather than write software at this stage, we can grab the first program by clicking on File, Examples, 01, Basics, Blink. Printing Hello World is typically the first program that is run in any software course, but with the Arduino, it's the Blink sketch. The program should appear in the text box and we will examine it later. For the moment, we need to know how to check that it is correct and how to load and run it on the Arduino. There are two circular buttons at the top of the package. Click the first tick box to verify that the code is correct. It should be. Clicking on the second right arrow button also checks the code before compiling it. Compiling is the process of taking the code and turning it into ones and zeros that the Uno understands. This process can take some time, particularly on the Raspberry Pi. The progress is shown in this bar. Once completed, it automatically uploads the results to the Uno. The yellow flashing lights here confirms the transmission. The Uno has been sitting and waiting for this code and will run or execute it once it's received. The program is a simple one that just tells the Uno to flash the other yellow LED every second, and this is what it should be doing now. This process of retrieving or even writing code, compiling it and uploading it to the Arduino will become very familiar as we repeat it during the course of these videos. The Uno remembers the uploaded code even when it's been disconnected and will automatically rerun it next time the power is applied to the board. Let's now have a quick look at the code. It can look quite intimidating at first glance with all the semicolons, brackets and braces, but it'll all soon become clear. Examining this program is made easier because all of the comments placed in it by the programmer. In fact, the first 6 lines are helpful comments to us. The /* and */ surrounding the block comments tells the compiler to ignore these multiple lines as they are not written for the Uno. Comments on single lines begin with double slash. They can appear at the start of the line or midway like here, here and here. The compiler again ignores anything on a line after double slash. Fully understanding the rest of the program at this stage does not matter, but we'll quickly go through it and it will soon become familiar shortly. So the first real programming line sets LED to 13. The comment on the lines above explains that pin 13 is also connected to the yellow LED wishing earlier. Notice that the line finishes with a semicolon. Although this has been mentioned now, you will forget to place a semicolon at the end of the line of one of your programs at some time shortly. Everybody does. Once any values are established, there are only two parts to any Uno program. These were referred to in the previous video. Part 1, the setup, configures the Arduino pins as either inputs or outputs. Part 2 is the program that continually loops thereafter. It's worth looking at the general format here and now, as it will occur time and time again, and using the wrong brackets, or missing a bracket, will be another source of programming error. To distinguish, we need to use the term bracket and curly braces. So we have void set up a pair of brackets followed by a pair of curly braces, and the same for void loop. The two parts of the program fit into these sections. As we only need to flash the LED on pin 13 here, the setup is fairly simple. The important command is pin mode LED output, semicolon, i.e. set up the LED pin, pin 13, from the integer above, to be an output. There are a lot of little gotchas in this line. Note first that pin mode is a special word, with the M in mode capitalized. This form of typing is called camel case. Output is in capitals, and again there's a semicolon at the end of the line. That's it for part 1, the setup. Part 2, the bit that loops forever, as the comment says, has 4 lines. Digital write is another special word, so it's written in camel case. The first and third lines make the LED pin high, on, and then low, off. In between are 2 lines that are the same. Delay is what is known as a function, and the function has the effect of putting a delay in the execution of the program. But how long? Well, the value is provided in the brackets. It's 1000, but 1000 what? This is where you may catch a glimpse of exactly how quickly the Arduino works. This 1000 means 1000 milliseconds, i.e. 1 second. So reading the computer program in the loop says, turn on pin 13 and wait for a second, and turn off pin 13 and wait another second, and just keep looping. That is it. Breaking things and seeing what happens is a learning process, so try introducing errors into the program and observe the reaction. Errors are displayed in this pane. Remove a semicolon and notice how the system complains and fails to upload the program. Notice also how the text editor in the integrated development environment helps you by color-coding the text as you type. It operates a little like a spell checker in a normal text editor, but has been modified here specifically for Arduino sketches. Its features like the helpful color coding in the text editor, the code checking, and the fact that the system stops you from uploading incorrect code all in one piece of software. That is why it's called integrated, all in one. It will help you develop more error-free code, hence the title, Integrated Development. We've covered a lot of basic ground in this video, parts of which will become very familiar as they're repeated in forthcoming episodes. Downloading and installing the Arduino Integrated Development Environment is something that should only need to be done once. A copy now exists and should remain on your machine. The IDE has been configured specifically for the Arduino Uno, and the USB port it is connected to on your machine, which may vary from the one given in this example. The example program Basic01 Blink was loaded, compiled and then uploaded to run on the Arduino. The first program Blink was examined. It contained a good deal of human-readable comment not needed by the Arduino and removed during compilation. There were 2 parts of the program that followed the initial settings of variables. The first part set the direction of the pins, and the second part described the loop that the Arduino continued cycling. Next, in the next video, we program the Arduino to return the values read from an analog input.